Hi, let's go over practice 3 in preparation for your long test 3. So let's start by looking at question number 1. Graph the given function by making a table of coordinates. So let's complete the table here. Type integers or fractions. Simplify your answers. You make sure to simplify your answer. Now to complete the table, all you need to do is to replace the x here by the given value of x here, and then evaluate the function at that x to get the y coordinate. So first, let's get the corresponding y value when x is -2. So that is f of -2. And that means 2/3, 2/3, and then replace the x here by -2. Now to simplify that, we will have to make the exponent here positive. To make the exponent positive, we use the loss of exponent. That means you're just going to get the reciprocal of the base here. So that makes it 3/2. And then you change the exponent to positive. Then you simplify. So 3/2 squared means 3 squared over 2 squared. So that is equal to 9/4. The next, you get the corresponding y value when f is equal to -1. So you have 2/3 raised to -1. Now let's make the exponent positive. To do that, you just get the reciprocal of the base. So you have 3/2. Then change this to positive. So that is just the same as 3/2. Then you distribute the exponent, both to numerator and denominator. So for the first part here, you just have to type in 9/4. And here, you would have to type in 3/2. Then here, for the third one, you have the value of y when x is 0, so f of 0. So you have 2/3 to 0. And remember, any number when raised to 0 is equal to 1. Any number except 0 when raised to 0 is equal to 1. So this is just 1. So that's an integer. The next, you have x equals 1. So you have f of 1. So you have 2/3 and then replace the x here by 1. That is just the same as 2/3. Then lastly, you have y, f of 2. So you replace the x here by 2. So 2/3 raised to 2. Then distribute the exponent. That's 2 squared over 3 squared. So that is 4/9. So this is 2/3. And this is 4/9. Then that's your table. And then now you look at the points here. You see here, this is actually equal to, so this is the corresponding graph with these coordinates. As you could see here, when x is equal to -2, y is 9/4, which is 2 1/4, so a little bit over 2. And then when x is equal to -1, when x is equal to -1, it's equal to 3/2, 1.5. So this is 3/2. Then when x is 0, y is 1. When x is 1, y is 2/3, and when x is 2, y is 4/9. So letter B is the graph. Next number. Use transformation of the graph of f of x equal to e to the x to graph the given function. Be sure to give the equation of the asymptote. And then use the graphs to determine each function's domain and range. So you're given here the function h of x equal to e to the x minus 2 minus 3. So first, let's choose the transformations needed to graph the function. Now, using the knowledge we had from Unit 1, if we begin with this parent function e to the x, the -2 here indicates a shift or transformation along the x-axis, a horizontal shift. So this means that there is a horizontal shift. Now the negative sign here means to the right. So it's the opposite. So that means there is a horizontal shift of 2 units to the right. So a horizontal shift of 2 units to the right. Now for the for this -3 here, that means there is a horizontal shift or translation along the y-axis, so a vertical shift. Now the vertical translation follows the sign here. So if it's negative, that means 3 units down. So if you look at the choices, so the graph of e to the x should be shifted to the, we know it's to the right. So to the right by 2 units, and then now this means downward by 3 units. So to the right by 2 units and downward by 3 units. So D will be the answer. The next, what is the asymptote? The asymptote for the graph here. The asymptote, if you recall, for e to the x, the asymptote will just be y equal to 0. So it's the x. So if you recall, the graph of the rough sketch for e to the x, this is an exponential function, an increasing function that would look like this. Now, this is the asymptote. That's the horizontal asymptote, and the equation for that is y equals 0. Now, because of the vertical shifting here, we know that there is a vertical translation of 3 units down. So that means that the asymptote will also be shifted 3 units down. So it will go 3 units down. 1, 2, 3. So this is the new asymptote. So that means the new asymptote becomes y equals -3. So that's the asymptote. So if you type in the answer here, you would just type in y equals 3. And then for the domain of the function, you don't need to compute for that. For exponential function, the domain is always the set of all real numbers. Okay, so let me just write the asymptote. You just type in y, so you include the variable y, not only -3, because that could mean x equals -3, so that makes it incorrect. So you have y equals -3. Again, include that variable y. And then for the domain, you would always write the set of all real numbers. And how do you write that? It's the interval from -infinity to infinity. Okay, then for the range, how would you graph the range? So for the range of the function, we have this exponential function. Now, when you, let's take a look at, so this function here will be shifted 2 units. So let's take a look at that point. It will be shifted 2 units to the right. So 2 units to the right. So 1, so this point here will go 1, 2, and then 3 units down. And then it will go 1, 3 units down. So it's 1, 2, 3. That's 3 units down. Then it will go here. It will look like that. Okay, and of course the y coordinate will be this curve here. So that's the rough sketch of the graph. So if that is the sketch of the rough sketch of the graph for h of x, so for the range, it will be the set of y values, the y values, right? So now you would always start, in this case, because it's increasing, it's above the asymptote. So the range will be from the asymptote. So let's do, so for the range, you start at -3, that's the asymptote, up to positive infinity. So the y value. So it goes up to positive infinity. Now you don't put this one because that indicates -3 is included. -3 is not included, so it will be an open interval. So -3 to positive infinity. So that's the range, the main. Now you can graph this. So to graph the function, you can just use that exponential tool, and then click the graph to plot the curve. So let's start here. We know that, okay, and then you edit this. So that's for e to the x. And then we know that there is a horizontal translation of 2 units to the right. So that's why it's positive. And then a vertical translation of 3 units down. So 3 units down. 3 units down. That's it. So that's how you would graph it. Okay. Then don't forget to graph the horizontal asymptote. The horizontal asymptote is this line here. That line. And another line. So that's the line y equals -3. And you make that a broken line. And then you save it. So this is the curve. That's the graph of e to the x minus 2 minus 3. Okay, so for the next question, we are to use the compound interest formulas, either this or this formula, to solve the given problem. And we are to round off our answers to the nearest cent. So we are to find the accumulated value of an investment of $15,000 for 7 years at an interest rate of 4% if the money is A, compounded semi-annually, B, compounded quarterly, C, compounded monthly, and D, compounded continuously. Now, this first formula here is the formula that you're going to use if you have a compounding interest periodically. So either semi-annually, annually, quarterly, monthly, or daily. This is the formula that you're going to use. So you change the n here. N is the number of compounding periods. T is the number of years, and R is the rate of interest. This formula here, the other formula, is the formula for compounded continuously. Okay, so the first from A to C, we're going to use this formula here. Okay, so let's go ahead and do that. So now, for P, that's the principal. That's the initial amount invested. So you would replace P by 15,000. And then the 7 years here is for your T. That's a number of years. And the rate of interest, R, is 4%. And you write that in decimal form. And then N is the number of compounding periods. So if it's semi-annually, N is 2. If it is quarterly, N is 4. And if it's monthly, N is 12. So let's write that down. Okay, so if it's semi-annually, N is 2. Quarterly, N is 4 because there are 4 quarters in a year. Monthly, there are 12 months in 1 year. So N therefore is 12. That's the number of times you applied interest. So for letter A, let's do letter A. Let's set that up. To compute for the accumulated value, you compute for A, you replace P by 15,000. So you have 15,000 times 1 plus, now the rate, you write this in decimal. So that would be 0.04. So replace the rate as 0.04, and N is the number of compounding periods. So for letter A, N is 2. And then 2 times the number of years, which is 7. Then you go ahead and plug that into your calculator. Now, since we'll be using Desmos Scientific Calculator on the test, let me go ahead and show you how you would input that to a Desmos calculator. So on your test, you make sure to open this tab, open a new tab on your test, and then the link also is provided for the scientific calculator. If you can't find the link, just go ahead and open the Desmos Scientific Calculator. You should be able to use that during your test. Okay, so let's go ahead and plug this in. So you have 15,000, that's our principal. So 15,000 and times parenthesis 1 plus, and then the fraction, that's the rate. The rate is 4%. So you have 0.04 divided by 2 semi-annually. Then you click this for the power. Then make sure to put the parenthesis. So you have n, which is 2, times the number of years, which is 7. Okay, now make sure we have that correctly. So 2 times 7. Make sure you write this correctly. You compare them. So that's right. That's what we're looking for. And then this is the value. So this is the accumulated value. We are asked to round it off to the nearest cent. So you look at 2 decimal places here, and then after that 2 decimal place, you look at the number to the right. If that is greater than or equal to 5, you add 1 to the number here. If not, you're just going to drop that number. In this case, since this is 1 and that's less than 5, we're just going to drop all the numbers here. So this one here, the highlighted number, is the number that you're going to input for letter A. So that's 19,792.18. Now for letter B question, you are asked to find the accumulated value if it's compounded quarterly. So you follow the same formula here. So on your calculator, you will just copy that formula. You copy that. And then what you're going to do is you're going to just change n. Okay, you're just going to change n here. And then we'll paste that. Now you're just going to change n here to 4. Since it's compounded quarterly, this 2 here will become 4. So because that is for n, so n becomes 4. And this is the value. And then again, you just do 2 decimal places. Now make sure to check the number to the right of that second decimal place and see if this number here is greater than or equal to 5. If it is, you add 1 to the number here. In this case, this is 4, so we'll just copy this. The highlighted number here is the number you're going to type in to the answer, to your test. Okay, so that would be the answer. Now, similarly, for letter C, if it's compounded monthly, then this one here, you're just going to change that 2 to 12. Okay, so this number here will be the amount that you are going to type in. But in this case here, if you look at that 0, the number next to it is 7, and that's greater than or equal to 5. So that's greater than 5. So that means you're going to add 1 to 70. So the answer will be 19,837.71. That's what you're going to input to your test. Now for the last one, we have here for letter D, that is for compounded continuously. You are going to use the formula here for compounded continuously for letter D. So A will be, so the P is the principal, that's this 15,000 in this case. And then we have E. E is the Euler's number. R is the rate, so that's same 4%, 0.4, times the number of years, which is 7. So times 7. So on your calculator, you would input 15,000. E, so E can be found here. So function e to the x, that's already for the power. And RT, so R, let's put a parenthesis because we are going to multiply this by something. So 0.04, that's 4% times 7. And close it. This is the value, the amount that you would plug in. And you make sure to add 1 to 4 here, because this number, the number next to 4 is 7. So the answer is 19,846.95. So you add 1 to 4. That is the number, that's the value for letter D. So next question, suppose you have to invest 11,000. So you have 11,000 to invest. Which of the two rates would yield larger amount in 2 years? So you have 12% compounded monthly or 11.90% compounded continuously. So you're just going to use the formula. This is for monthly compounding. So that means in the formula, you're the same for this problem here. You use this formula here for the first option, and this is for the second option. That's the formula for compounded continuously. So in this problem, we are going to plug into our calculator A. We'll compute for A. The principal is 11,000. And then 1 plus the rate. So rate is, that's 12%. In this case, write that in decimal. So rate would be 0.12. Rate is 0.12. So that will be 0.12 over, so that's R over N. So this is compounded monthly. So N is 12. Raised to NT. N is the number of, N is 12, the number of compounding periods. That's 12 times the number of years. So this is in 2 years. So T here is equal to 2. So times 2. That's what you're going to plug into your calculator. And then for the other one, for the other option, you're going to use the formula PE to the RT. P there is equal to 11,000 times E, and then the rate is this rate here. You have to write that rate in decimal. So move the decimal point 2 places to the left. So you do that. So you have 0.119. So you have 0.119 times the number of years, which is 2. Then you plug that into your calculator. All right, so let's go ahead and plug that in here. So maybe we can just edit this or just start a new one. So we have 11,000, that's our principal, times 1 plus the rate is 12%, so that's 0.12, and then 0.12 divided by our N, that is compounded monthly, so N is also 12, and then raised to N. N is, so this is a power, parenthesis, N is 12 times the number of years, which is 2 years. And this is the value. Okay, so for the second option, so we're going to compare that to the second option wherein it is compounded continuously. So that's P E to the RT. So this is where you can find E to the RT. So R is 11.90%. So if you remember, it's 11.90%. So that's 0.119. So this is 0.119, 11.90 times 2 years. Then close that. All right, so you compare these two values. Which one would yield the larger amount? This first one here, compounded compounded monthly, at 12% compounded monthly. So that is the answer. So in this case here, it is the first option that would yield a larger amount in 2 years. Next, write the following in its equivalent exponential form. So if you have logarithmic, you can write it in exponential form. So you can do this. The number you see here is the base. So you have 4. The number you see here is the power. So 4 to the y is equal to the number here, which is 64. So 4 to the y is equal to 64. That is the exponential form of the logarithmic equation here. Next, graph 5 to the x and g of x equal to log of x base 5 in the same rectangular coordinate system. For this problem here, you are actually being tested whether you know the relationship between these two. So I hope at this point you know that these two are just inverses of each other. So 5 to the x, the inverse of f of x equal to 5 to the x is log of x base 5. And then also, you remember that if the two functions are inverses of each other, their graph are just the graph of the inverse of the function is just a reflection of the graph of the function along the line y equals x. So in other words, if you graph 5 to the x, f of x equals to 5 to the x. We know if you have an exponential function with base greater than 1, if you have an exponential function of base greater than 1, the exponential function will behave like this. So it's an increasing function. Suppose this is the graph of 5 to the x. So the graph, the function 5 to the x will behave like that. It's exponential and increasing. Now its inverse will just be, the graph of its inverse is the reflection of the graph of this curve here along the line y equals x. So suppose this point here is always equal to 0, 1. Now on its inverse, that becomes 1, 0. And then this curve here, when reflected along this line, will be this curve here. And that curve, when reflected along that line, will be this curve. So this is the graph of log of x base 5. So if you look at the choices, which of the two would be which of the choices here would be a good candidate? It's actually this, this choice here. And you can go ahead and look at this more closely. Okay, and examine that. So we have this is the graph of 5 to the x, which is increasing. And then see if you can draw a line here, y equals x, and you reflect this green curve along that line, y equals x, and see if the graph is traced like this. All right, so let's trace that. So this is the line y equals, that's the line y equals x. That's the line y equals x. So notice that this curve here, that part of the curve, when reflected along this line here, will actually go here. And this part of the curve that approaches the line y equals 0. So then if it is reflected along the line y equals x, it will go to the line, it would approach the line x equals 0, which is the y-axis. So indeed, this is the graph of the two functions on the same coordinate axis. So the next question is similar to the previous one, but here the base is 1/8, 1/8, which is a number that is less than 1. So if you remember, if you have an exponential function with base that's positive but is less than 1, the curve in general will be a decreasing function. So it will behave like this. So a curve, it is a decreasing function if the base is less than 1. So this one will behave like this. And then this is the inverse. This log of x base 1/8 here is the inverse of the exponential function 1/8 to the x. So that means that the graph of this function will be the reflection of the graph of f of x along the line y equals x. So if this is the curve for the graph for 1/8x, So you would just reflect this curve here along this line. So it goes here, and then this part of the curve, so that's this part of the curve here, will be reflected here. Now this part of the curve, when reflected along the line y equals x, would actually go here. It will go there. So we're looking at the graph that would be similar to that. And which one would it be? Right, so we have two candidates. Looks like we have this, and the other one is that. More like this, right? More like letter D. So let's take a look at letter A first and see why that is not the answer, or why it's the answer if that's possible. Okay, so let's take a look at that. Let's expand this. So suppose, for instance, this one. Let's see. So, for instance, this blue curve here, if that is the graph for 1/8 to the x, so that's the graph of our exponential function. To get the inverse, to get the graph of the inverse function, we're going to reflect that along the line y equals x. This is the line y equals x. So that means this blue curve here, when reflected along that line, would actually, as you notice here, it approaches to your x-axis. So therefore, its reflection should approach the y-axis, right? And then this part of the curve here, when reflected along that line, would actually go here, like that, okay? So that means that this red curve here is not the graph of the inverse of the blue curve. So A is incorrect. So we should somehow look at a graph that behaves like that. And that is actually this curve here. This curve here, which is letter D. That is the graph of 1/8 to the x and of f of x and g of x in one coordinate system. So next, this is still in graphing. Use transformation of the graph of log of x. So we are going to transform the graph of log of x to determine the functions, use the transformations of log of x to graph the given function. So we're going to graph 7 minus log of x. And then you determine the domain and range of the function. So first, let's just determine the transformation needed to graph to graph g of x coming from f of x. So the negative sign here, you see log of x is negated. That means there is a reflection. Okay, so this is reflection. There's a reflection about the y-axis. So you know the x-axis, sorry. There's a reflection about the x-axis. So this is reflected about the x-axis. So know that there's a reflection about the x-axis. Now, you have a plus 7. Because that's a positive 7. 7 minus log of x. So that means there is a vertical shift. A vertical shift of 7 units to the, is it up or down? So it is upward because it's positive. So we know log of x should be reflected about the x-axis and vertically shifted 7 units upward. Letter B is the answer. Now next, to graph this function, you're just going to click on the graph here and use the logarithmic tool. So you're going to pick whether you logarithmic tool, because that's a logarithm. So you're going to click logarithm, and then you click on, now if you remember, if the base, so if you have logarithmic function and the base is greater than 1, that's greater than 1, like in this case here, the base is 10, you have an increasing function. So a logarithmic function, your graph would look like this for logarithmic function. That's an increasing function. So this is when the base is greater than 1. If the base is greater than 0 but less than 1 for logarithms, you will have a decreasing function that would look like this. The curve would look like that for logarithm. Now in this case, it is this one. It's an increasing function because the base is 10. So here you copy that, and then now it would always pass through the point 1, 0. And then you input here your horizontal shift if there is any, or if there's a reflection. So we know it is reflected over the x-axis. So it's reflected about the x-axis, and then there is also a vertical shift. There's a vertical shift of 7 units, and then you just type in 7 there. 7 units. 7 units for the vertical shift, and again, it's reflected about the x-axis. Oh, I kept on adding that. Let's start over again. Okay, so again, you do that. You click on this tool here, click a point there, and then put the vertical shift, put 7, and then click on reflect over the x-axis. The base is 10 because we know that's base 10. If it's a different base, you also change the base. All right. And then what is the vertical asymptote? The vertical asymptote, you're just going to look at the expression here. There's no translation about the x horizontally. There's no translation horizontally. So you're just going to get that expression. Let me just write that down. You're going to get this expression, that x there, and you're going to do greater than, that's the domain. So the asymptote will just be equal to, you equate that to 0. So in this case, it is just x equals 0. Then for the domain, you do that same thing, that expression over there, and then you make that greater than 0, strictly greater than 0. That's the domain. Now we are to write our answer in Interval notation. How do you write this in Interval notation? In Interval notation, that is, so again, 0 is not included, so it's open parenthesis, from 0 to positive infinity. Okay, so that's for the domain. Now the range is always the set of all real numbers. As you can see here, whatever the behavior is, it's always the set of all real numbers. So this is the asymptote, and this is the domain. Now for the range, you don't need to think about it. It's always the set of all real numbers, negative infinity to positive infinity. Now next number, find the domain of the logarithmic function. So you are given here log of 13 minus x. You are to find the domain of that function. How do you do that? The shortcut is to just get the expression here. So that expression, you copy that. So you have 13 minus x, and then you make greater than 0. You make that positive. You want to solve for the values of x that will make this expression here positive. So that makes that expression positive. So just solve for that inequality there. So you have 13, you move negative x to this side. So it's like adding plus x on both sides. So you will have 13 greater than x. So, or that means also x is less than 13, right? This means x is less than 13. And how do you write that in Interval notation? You're going to write that in Interval notation. This is, so x is less than 13. So that means negative infinity to 13, open, because there's no equality there. Or you can first graph it if you're a little bit confused. So you do 13 here. You say less than 13, and then you shade that. That's less than 13. So that will be the interval from negative infinity up to 13. You make sure not to include 13 because there's no equality sign there. Now for the next number, we are to evaluate the expression without using a calculator. So how do you do that? First, let's evaluate or simplify the one inside the parentheses. So the one inside the parenthesis, log of 5 base 5. So for logarithm, logarithms are just exponents. So you have to remember the definition of logarithm. So let's review. If you have y equal to log of x base b, this means that this is the same as b. So you think of b is the base, and the exponent is y, and the number is x. So here, if you are to evaluate something like log of 5 base 5, so you would think of where to raise 5, this number here, so that you get 5. So that means 5 raised to what is equal to 5? Where would I raise 5 so that I would still get 5? That means 1. You just raise it to 1. So this is 1. Because we know that 5 to the first power is just equal to 5. So this is equal to 1. In other words, the one inside the parenthesis is 1. So you have log of 1 base 3. Now for log of 1 base 3, log of 1 base 3, you think of, so how do you find the answer for that? So the base is 3. Where would I raise 3 to obtain 1? What would be the exponent of 3 so that the answer that would result to 1? If you remember, any number when raised to 0 is equal to 1. So we know that 3 to the 0 is 1. So this means that log of 1 base 3 is just 0. So this is just 0. So let's have another example. Evaluate this expression without using a calculator. This is similar to the previous one. So how do we do that? We first simplify the one inside the parentheses. So let's simplify this. You have log of 32 base 2. So how do you do that? You think of where, so you would think of where to raise 2 to get 32. What should be the exponent of 2 to get 32? So in your calculator, you keep on multiplying 2 to itself, and you count how many times should you multiply 2 to itself to get to 32. And when you do that, you would then see that you have to multiply 2 to itself 5 times. You know, 2 to the 5th is equal to 32. So this is equal to 5. So log of 32 base 2 is 5. So this is just equal to log of, this is 5, log of 5 base 5. Now, log of 5 base 5, how do you do that? You think of where to raise. So for log of 5 base 5, you think of where to raise 5 to obtain 5. We know that 5 to the 1 is equal to 5. So this is equal to 1. So that's equal to 1. All right, so number 12, use properties of logarithm to expand each logarithmic expression as much as possible. Evaluate logarithmic expressions without using a calculator if possible. So here we are going to expand this. So that means we're going to use the properties of logarithm. So what are the different properties of logarithm? We usually have 3. So we have the logarithm of the product, xy, base b is equal to the sum of the logarithm. So log of x base b plus log of y base b. Now, the logarithm of the quotient, if you have x over y base b, this is equal to log of x base b minus log of the denominator y base b. So think of loss of exponents. Logarithms are just exponents, so that means they follow the rules of exponent. So if you remember, if you are multiplying two expressions with the same base, so x to the n times x to the m, loss of exponent, this is just x to the n plus m. That's why here, if you have logarithm of the product, that is just equal to the sum of the logarithms, the sum of the exponents, the sum. And then for quotient, that's the difference, right? And then also the last one is the power rule. So if you have x to the r base b, this is equal to r log of x base b. So you can bring down the power here. So here, to expand this, we would have to first apply the product rule. So that would be log of x to the 7 base b plus log of y base b. So this is what you would write on your scratch paper. And then you apply, so you're not done after that. You have to apply the third rule, which is the loss of exponent. I mean the power rule. So you bring down 7. This becomes 7 log of x base 6, base b, sorry, not base 6, base b plus log of y base b. So this is the expanded form. So again, let us expand the following expression using the properties of logarithm. So to do that, we are going to here first, let's apply the quotient rule, So this over this. So that means log of x cubed y minus log of z squared base b. Then you copy the base. Next, we're not done yet. We are going to apply here the product rule. So you have log of x cubed base b plus log of y base b minus log of z squared base b. Now with all those power, you have to apply the power rule. So this is 3 log of x base b plus log of y base b minus 2 log of z base b. This is the expanded form. Next, we are asked to condense the logarithmic expressions. You're given the logarithmic expression in expanded form. Now we are going to condense it. Write the expression as single logarithm whose coefficient is 1. And then evaluate logarithmic expression if possible. If you could simplify it, you simplify it. Okay, so here, first, if you are given the expanded form and you're condensing it, the first one that you have to apply is the power rule. That means you remove the coefficients here. So you would have ln. ln means logarithm base e, correct? So you have ln x to the 6 minus ln y to the 1/4. Okay, ln y to the 1/4. Then you combine them. So now, if there is no more coefficient, that's when you can apply the quotient rule. So you will have ln, this is the numerator, x to the 6 is the numerator. Now, y to the 1/4 is the denominator. Now, 1/4 means the 4th root of y. So that is ln x to the 6 over the 4th root of y. That is the condensed form. So in this problem, in this item here, we are asked to condense the logarithmic expression, the expanded logarithmic expression here. And we make sure that it is just written as single logarithm with coefficient equal to 1. Right, so to do that, as I've said, we first have to remove that coefficient there. So that means we have to apply the power rule. So first step is to write this as ln x cubed plus ln y to the 5th minus ln z to the 4th. Then sum means you multiply. So you have ln x cubed y to the 5th divided by z to the 4th. That's the condensed form. So in the next example here, you are asked to use common logarithms or natural logarithms in a calculator to evaluate the expression. So you are asked to evaluate log of 13 base 14. So to do that, we are going to, sometimes we will be asked to set up. So it's important that you know how to use your change of base formula. Or, some calculators, or probably the calculator here, let's look at Desmos calculator. The Desmos calculator has the logarithmic function. It has, okay, so it only has ln or log. And how are we going to evaluate that logarithmic expression? Just using either natural logarithm or the common logarithm. So to do that, this is just, we would use the change of base formula. This is just equal to log of 13, that is using common logarithm, log of the number here divided by the logarithm of the base, which is 14. Yeah, and that's what you plug into your calculator. Or if you want to use ln, you can just say ln 13 over ln 14. And then you plug that into your calculator. You plug this into your calculator, and then you round off to 4 decimal places as needed. Okay, so this is what you type in to your calculator. And you would arrive at the same answer. So see, if you have ln of 13, see ln of 13 divided by ln, go back there again, ln of 14, see, so that's the value. Now if you use common logarithm, you arrive at the same answer. So you have log of 13, you get the same value as you do log, I'll show you, 14. See, you arrive at that same answer. So it doesn't matter which base you use. Either you use the natural logarithm or the common logarithm. You arrive at the same answer. 4 decimal places. So make sure you know how to round off. All right, next problem. We are asked to solve the exponential equation by expressing each side as a power of the same base, and then equate the exponents. So here we have 2 to the 2x minus 2 equal to 4. So again, we are to express each side as a power of the same base. So that means you can write, or you would have to write 4 as base 2. So we know we can write 4 as base 2. That is 2 squared. So 2 squared. So now that they are of the same base, you're just going to get the exponent. So 2x minus 2 and the exponent here. And then you equate them. You equate the exponent. So 2x minus 2 is equal to 2. Then you solve for x. So you have 2x. You add 2 on both sides of the equation. So this is plus 2. That becomes 0. That becomes 4. So 2x is equal to 4. Then you can divide both sides by 2. So x is equal to 2. The solution set is x equals 2. So you just have to write 2 here. So next we are to solve for this exponential equation by expressing each side as a power of the same base. So in this problem here, we are to express 1 over e also as base e. So you can write that as, 1 over e using laws of exponent. This is just e to the negative 1. E to the negative 1. So we have e to the x plus 6 is equal to e to the negative 1. They have the same base, so therefore you equate their exponents. So x plus 6 is equal to negative 1. And then you subtract negative 6 on both sides of the equation. So you have x is equal to negative 7. So the solution set is negative 7. So for the next number, we are to solve this exponential equation. Express the solution set in terms of natural logarithms or common logarithms. Then use a calculator to obtain a decimal approximation for the solution. So that means you are to find first the exact value, and then you are to use your calculator. So we want to solve for that x there. So to solve for that x, to solve for this x, since we cannot write 131 as base 7, then what you can do is you just take the ln of both sides. That is using natural logarithm. You can either use natural logarithm or common log. So either you take the ln of both sides or the log of both sides. So you do ln of 7 to the x is equal to ln of 131. Then use the power rule. So you can bring down that x. This is x. ln 7 is equal to ln of 131. So therefore x in this case is just equal to, you divide both sides by ln 7. ln 7. So that cancels. So x therefore is just ln of 131 over ln of 7. And that's what you would type in here. Okay? So you type in ln of 131 over ln 7. And then also, you can plug that into your calculator to get the approximation. And you round it off to 2 decimal places. So in this case here, you just plug this into your calculator, and then whatever the answer is will be plugged in here. So next, it's the same thing. We are to solve for x here, but since we cannot write 138 as base 5, then we will just have to take the ln or the logarithm of both sides. And then you solve for the equation, solve for x. And that's what you plug in here. Okay, so to illustrate that, let's go ahead and take the logarithm of both sides. So you take ln of both sides. So you have ln 5x minus 2 is equal to ln of 138. Then you use the power rule. You bring that down. So you have x minus 2, quantity ln 5, is equal to ln of 138. Then you have x minus 2 is equal to ln of 138 all over ln 5. Then you solve for x. So x is equal to ln of 138 over ln 5 plus 2, because you move that to the other side of the equation. This is what you would input in here. Okay, that's what you would input there. Then for the solution set, you are going to plug this into your calculator and then type in the answer here. And make sure to round off to 2 decimal places as needed. So you know how to plug that into your calculator, right? So you will do, for using Desmos calculator, you are going to plug in ln of 138 over ln 5. So you have ln of 138 over ln 5, and then there is a plus 2, so plus 2. Okay, so this would be the value. And then it says there to round it off to 2 decimal places, so you're just going to copy that. You drop the rest of the numbers here since this is 1 and that's less than 5. Okay, so now let's consider the next problem. Solve the following logarithmic equation. Be sure to reject any value of x that is not in the domain of the original logarithmic expression. So, in other words, you have to check your final answer later. Right, so to solve for the logarithmic equation here, the first step is to write this in exponential form. So you would have 2, copy the base, and then the exponent is 4. So 2 to the 4th is equal to x plus 25. So write it in exponential form. Then you solve for x. So what is 2 to the 4th? 2 to the 4th, you plug into your calculator, that's equal to 16. And then you have x plus 25. You solve for that equation. So you move 25 to this side of the equation. So you subtract both sides by 25. So that means 16 minus 25 is equal to x. So therefore, x is equal to -9. Now, before you type in -9, you make sure that it is within the domain here. So what is the domain of the original logarithmic expression? So what's the domain of this? You're just going to look at x plus 25 and then make it greater than 0. You want to make sure that's positive. So if I plug in -9 to x here, -9 plus 25, that is equal to 16, and that is greater than 0. So that means it is in the domain of the expression. So it's positive. So in other words, what you would do is you get that value of x, you plug that into the original expression, and you make sure that the expression here is positive. The argument is positive. And if that's the case, then that is a solution. And this is a solution. So the answer is -9. The solution set is -9. So for the next question, we are asked to solve for the logarithmic equation. And then you make sure to reject any value of x that is not in the domain of the original expression. That means you have to check if the answer you got satisfies the given equation. And make sure, so the first step is to rewrite the given equation without logarithms and do not solve for x yet. So to do that, we look at the expression here. We are to rewrite this without logarithm. So we're going to use the definition of logarithm. We write it in exponential form. So first step is to look at this one. We have a 2 here and a 10 here. That means we can divide both sides by 2 first. So this is equal to 5. So in other words, we have ln 6x is equal to 5. Then we can write that in exponential form. So ln is just logarithm base e. So this is e. This is equivalent to e. The base is e. The exponent is the number here. So e to the 5th is equal to the expression there, 6x. So that is what you're going to write here. So you're going to write here 6x is equal to e to the 5th. Or you can write e to the 5th is equal to 6x. That is your equation. The next, what is the exact solution? Then that means you just have to solve for this equation here. So you can divide both sides by 6. So x is equal to, so what you would type in here will just be e to the 5th over 6. That's the exact answer. And then you are going to plug that into your calculator. To get the decimal approximation, you plug this into your calculator. And then you type in the decimal here, rounded to 2 decimal places. Next number, solve the logarithmic equation. This is the logarithmic equation. Find x. Be sure to check for extraneous roots, or check your answers. So to do this, to solve any logarithmic expression, the first step is to combine. Since this one has 2 terms, you have to combine this as single logarithm. So you're going to use properties of logarithm to combine them. So this is just the same as log. So since that is the sum, that means this is this logarithm of the product. So log base 4 of x times 3x minus 1 is equal to 1. And then you would have x times 3x minus 1 is equal to 4. So the base is 4, right? And then now you're going to simplify this expression. Okay, so you expand that, so you will have 3x squared minus x is equal to 4. Now you will have a quadratic equation. So this is the same as 3x squared minus x minus 4 equal to 0. Now factor. Try to factor this. So you will have 3x and then x here. Then you will have 4 here and 1 here. Let's see. If this one is negative and that's positive. So you can check. So this is negative 4x and that is positive 3x. If you add them, you get negative x. So, and then this is equal to 0. So therefore, you have 3x minus 4 equal to 0. And then x plus 1 is equal to 0. So x is equal to 4/3. And then here, x is equal to negative 1. So you have two values of x. So now, before you write the answer, you go back to the original given and you make sure that each of the expression here is positive on these values of x. Now, look at x equals negative 1. This is just x here. So this becomes negative if x is negative 1. So that means this is not part of the solution. So only 4/3 then is part of the solution because that's positive here, 4/3. Now, if you plug in 4/3 here, 3 times 4/3 is 4. 4 minus 1 is 3. So that is positive. So therefore, the solution set here is just 4/3. X equals negative 1 is not part of the answer. All right, let's have another example. So here we are to solve the logarithmic equation here and be sure to check for extraneous roots. So the first step is to write this as single logarithm. So this is minus, that means this is a quotient. So that's log of x plus 10, log of x plus 10 over 2 is equal to log of 5x plus 1. Now, since both sides of the equation are in terms of log and log has a one-to-one property, then you can just equate the expressions here, the argument here. So equate this expression to this expression or like cancel that logarithm. So this means x, you have x plus 10 over 2 is equal to 5x plus 1. Again, that is possible because you see logarithm on both sides. So if that's the case, you're just going to equate the expression here to the expression here. And then you solve for that equation. So you will have, you multiply both sides by 2. So you have x plus 10. So if you multiply this by 2, that by 2, you cancel 2 here. Then you have 10x plus 2. Then you move 10 to the other side. That's negative. That would be x minus 10. And then move this 10 on this side here. That's 2 minus 10. Then x. Okay. So you move this 10x on that side. So you subtract 10x on both sides, that cancels. You subtract 10 on both sides, this cancels. Then now, so in other words, you group all those with similar terms. So what is x minus 10x? It's negative 9x. That's equal to negative 8. Then you divide both sides by negative 9. So x is equal to 8 over 9. X is 8 over 9. Now you go back and check. So for instance, x plus 10. If this is 8 over 9 plus 10, that's still positive. So we're good. What about here? That is still positive. 5 times 8 over 9 is a positive number. Plus 1 is still positive. So therefore, the answer here is 8 over 9. Next number, the exponential model A equal to 1.29.7 e to the 0.003t describes the population A of a country in millions t years after 2003. Use the model to determine the population of the country in 2003. So this one, so this is t years after 2003. So t years after 2003. So if we're going to find the population of the country in 2003, that means that t is just equal to 0. So if t is 0, this is t0, you're looking for the initial condition. So the answer is just this, 129.7 million. So, or in other words, you just replace t by 0 and then you solve for A. E to the 0 is 1. So then you get, that gives you 129.7 million as the answer. So next problem, complete the table shown to the right for the half-life of certain radioactive substance. So you are to find half-life here. The decay rate and K is given. Now, what do you mean by half-life before we proceed? Half-life is the time required for the substance to decay to half of its value. And that's half-life. So it's the time. So we're looking for the time for the substance to decay to half of its value. So now to solve this, we are going to use the model A is equal to A sub 0, that's the initial amount, e to the kt. Now K here is the decay rate and A sub 0 is the initial amount and T is the time. Now as I've said, half-life, that means we're looking for this time here that is required for the substance to be half or to be reduced to half of its original value. So in other words, the A will be replaced by A sub 0 over 2. So you would have A, the original, this is the original amount. So it will be reduced by half. So it becomes 1/2 of A sub 0. So that means A becomes 1/2 of A sub 0. So you're going to solve for this equation now. So you have A sub 0 over 2 is equal to A sub 0 e to the kt. Oh, our K is the decay rate, and that is given to be negative 0.024 to the t. Now, both sides of the equation have A sub 0. So that means we can just cancel A sub 0 by dividing both sides by A sub 0 or multiplying both sides by 1 over A sub 0. So you can cancel that. So you have 1/2 is equal to e to the negative 0.024 t. Now to solve for the time t, you're just going to take the ln of both sides. So you take ln of both sides. So ln e will just be this power here. This right side here is just equal to negative 0.024 t. That's properties of logarithm. So ln e to the x is equal to x. ln e is just equal to 1. So now we have that. Then you divide both sides of the equation by negative 0.024 to solve for t. Negative 0.024. So therefore the the exact value for t is equal to ln of 1/2, that's also equal to negative ln of negative ln of 2. ln of 1/2 divided by negative 0.024. That's the exact value. And that is what you would input to your calculator. You would input this to your calculator and round it off to 1 decimal place. Okay, so this is how you would do it. So let's go ahead and input this to our calculator. So we have ln in the numerator, ln of 1/2. So ln of 1/2, and then the denominator is negative 0.024. Negative 0.024. Yeah. And then this is the answer. Round it off. We are asked to round it off to 1 decimal place. So this is equal to 28.9. 28.9 years. The half-life for this substance here is 28.9 years. So you would type in 28.9 here. So use the exponential decay model to solve the following. The half-life of certain substance is 23 years. How long will it take for a sample of this substance to decay to 75% of its original amount? So how are we going to solve this? So here, this is the half-life of 23 years. That means A sub 0 over 2 is equal to 23 years. So in other words, from here, we can compute for the original amount. So A sub 0, initially, it will just be equal to 46. So we want to know how long will it take for this sample for a sample of this substance to decay to 75% of its original amount. So the original amount is 46 from here, from the given. So you're just going to get 75% of 46. So A is 75%, so 0.75 times 46. So you plug that into your calculator. Let me multiply that. 75% times 46 is equal to 34.5. So, let me double check. Times 46. Yeah, 34.5. That would be 75% of the original amount. So we want to compute for the time, compute for T here when A is equal to 34.5. That is 75% of the original amount. The original amount is 46. Original amount is 46. We were plugging it in this equation here. E to the K. What is K? We don't know what K is. And we want to compute for T. So how do you compute for K? So to compute for K, let's look at some equation here. All right, so we can solve for K by actually using this information here. So we know from here that the half-life, so that is the time. The time required for A sub 0 over 2 is equal to A sub 0 e to the K, and that's equal to 23. So we know we can cancel this A sub 0 here, right? A sub 0 can multiply both sides by 1 over A sub 0. That you cancel. So you have 1/2 is equal to e to the K times 23. Then from there, you will solve for K by getting the ln of both sides. So we have ln of 1/2 is equal to ln e K 23. That is just equal to K times 23. ln e. So this part here is just equal to 23k. Then you can divide both sides by 23. That's by 23. So k is equal to ln of 1/2 over 23. So if you going back here, you will have 34. This k here, 34. I'll just copy that. 34.5, 46e, and then the k will be, k is ln of 1/2 over 23 times t. Now let's divide both sides by 46. And then you simplify that. And then you solve for t. Okay, so when you simplify this, that is just equal to 0.75. This is 0.75 is equal to e to the ln of 1/2 over 23t. Then now you take the ln of both sides. You take the ln of both sides. So this side of the equation here becomes, that cancels. So that becomes ln of 1/2 over 23 times t. And this is ln of 75. Now, to simplify this, let me write that. This one here is just ln of 0.75. I'll copy that. This side here, I'll copy that as well. ln of 1/2 over 23t. Now you multiply both sides by the reciprocal of this expression here to solve for t. So to solve for t, you will have ln of 0.75 times the reciprocal of this. So 23 over ln of 1/2. And that is what you would plug into your calculator. So on your Desmos calculator, let's look at the Desmos calculator. You will have to input this. So you will have ln of 0.75 times the reciprocal, which is 23 over ln of 1/2. So 23 in the numerator, and then you have ln of 1/2. So it's really good to use this Desmos calculator. It's very user friendly. So therefore the answer is 9 and this is a decimal. So let's look at what is being asked. We will have 2, so you would have to write the answer here, round it off to 1 decimal place. So the answer would be 9.5. So the answer is 9.5. 9.5, and then what's the unit? 9.5, approximately 9.5, you would write here, approximately 9.5 years. Okay, 9.5 years for the sample of the substance to decay to 75% of its original amount. Number 28, select the answer that best completes the given statement. This notation means that's the inverse of the function. F of -1 means the inverse of a function. Next, let's fill in the blank so that the resulting statement is true. If the given function g is the inverse of the function f, then f of g of x is equal to, if they're inverse, then this is equal to x. And also the g of f of x would still be equal to x. All right. Next, number 30. For number 30, find an equation for f inverse, the inverse of the function, and you verify by showing that these two are correct. So to do that, let's look at how to find the inverse of the function. You can find the inverse of the function by just using the two-step or following the steps here. 3 steps actually. So the first step is to write f of x as y. So y is equal to 2x plus 7. And then next is to replace x by y and y by x. So y by x, so y becomes x, and the x here becomes y plus 7. Then you solve for y. So you have x minus 7 is equal to 2y divided by 2. So y is equal to x minus 7 over 2. And then you write that as f inverse of x. So the inverse function, f inverse of x, is just equal to x minus 7 over 2. We obtained that by solving for the equation here, and this equation is obtained by just replacing the y here from the original equation by x and the x by y. That's the inverse. All right, now to answer the question here, so you would just have to write the equation here. Now, this one is for all x, because for the domain, let's talk about the domain of the function. The original function here, the domain of the original function is the set of all real numbers. When you get the inverse, that becomes the range of the inverse. And the domain of the inverse is the range of the original function. Now here, this is just a line. So a line, the domain of a line is the set of all real numbers, and also the range is the set of all real numbers. So that when you have the answer here, this one should be for all x. So you copy C, so that's for all, and then you would write down the expression here, x minus 7 over 2, write that down here, that's for all x. Now when you verify that the equation is correct. So that means that you are going to have f inverse of, that means you replace your expression here, your f inverse, you just copy the expression for f inverse. You would type in here. So you would write here, maybe let me copy that. So I think it's a lot easier. We do that. So what you would do, what we got here is x minus 7 over 2. And then that should result to x. And then here, your f inverse, whatever that is, will be replaced by the expression for f of x. What was the expression for f of x? 2x plus 7. And then that should, when you simplify that, that should be equal to x. Right, next, number 31. We are to find the inverse of this 1-to-1 function here and verify that this equation here is correct. So to do that, first you're going to write y, f of x is y, so you have y of x plus 7 quantity raised to 5. Then the next step is to replace the y here by x. So you would do x, that becomes x, and the x here becomes y. So you have y plus 7 to the 5th. Then you solve for x. How do you solve for y? So you solve for this equation for y. And how do you do that? First, you will have to you want to isolate y. Raise both sides of the equation to 1/5. And that would also be 1/5. So in other words, you have x to the 1/5 is equal to, this cancels. So y plus 7. So that means you have the fifth root of x is equal to y plus 7. Then you solve for y. Y is equal to, you subtract both sides by 7, so that's fifth root of x minus 7. Y is equal to the fifth root of x minus 7. So that would be your inverse. Now, which one is the answer here? The expression would be this one, the fifth root of x outside minus 7. What is the domain of this? This is true for all. Is it for all x? No, in this case here, there's a restriction for that domain. This expression here is only true, that is only true when x is greater than or equal to 0. So that is when x is greater than or equal to 0. You look at the domain of the resulting expression, your inverse. Okay, so and then you just type in here that expression, the fifth root of x minus 7. That would be the answer for letter B. And then verify that the equation is correct. Yeah, you can verify that. So here, what you would do, you would start by evaluating your f at the inverse, and the inverse is this. So you evaluate that as the fifth root of x minus 7. And when you evaluate your function at this expression, you should arrive at x. And here, the same thing here as well. Also, you evaluate your inverse, the inverse function at f of x. So what is f of x? The expression for f of x is quantity x plus 7 to the fifth. And when you do that, you should get x as your answer, and as your final answer. So if they're both equal to x, then that is actually verified. Now, you would have to do the work to actually verify if that is really right. So let me show you f of f inverse of x. So f, this is your f. You would replace the x there by f inverse. So you would have, so again, you would replace the x in f of x, the x in f of x by fifth root of x minus 7. And then now in your x here, you would replace the x by this expression. So you would have fifth root of x minus 7 plus 7 raised to 5. And what is that? You cancel this. You have the fifth root of x raised to 5. What is that? That is equal to x. So that's how you get x there. Now also you have f inverse of f of x. F inverse of f of x is equal to, now you're in the inverse, this is the inverse of our function, which is that. So that is the fifth root of, now the x there will be replaced by f of x, which is x plus 7 to the fifth minus 7. And this expression here, that cancels, so that is just x plus 7 minus 7. And then 7 minus 7 is just x. That is 0, right? So therefore this cancels, so you only have x. So you also have x there. So if that is true, then the equation is actually verified. It's verified that this equation that we got here is the inverse of the given function. So for the last number here, we are to find the inverse of the function. And we just follow those steps here. We call f of x as y. So you have y, 5x plus 3 over x minus 4. And then you replace x by y. So this is now x and y by x. So this is now x equal to 5y minus 3 over y minus 4. And then we solve for y. So we can do cross multiplication. So we have x times y minus 4 is equal to 5y minus 3. So you have xy minus 4x is equal to 5y minus 3. And then you combine similar terms. So you have xy minus 5y. Group all those with y, because we want to be able to isolate y. And then you move this minus 4x to the other side of the equation. So you have negative 3. After you move 5y on this side, you are left with negative 3. So you have negative 3 here. Then you move negative 4x to that side. So that becomes positive 4x. Now, we can factor out y. So y is equal to x minus 5 is equal to negative 3 plus 4x. Then you divide both sides by x minus 5. That is the inverse. So f inverse of x is equal to 4x minus 3. Addition is commutative. So I could write that as 4x minus 3 over x minus 5. So this is the inverse only when the denominator is not 0. So we have a rational expression here. So we don't want the denominator to be 0. That means x cannot be equal to 5. And so the inverse will be 4x minus 3 over x minus 5 for all x not equal to 5. Okay, so that's the inverse. And then you go ahead, I will leave this up to you for the letter B part here, where you actually have to verify. So all you need to do is evaluate the function at f inverse of x. So at this expression here. So at 4x minus 3 over x minus 5. And you should get x when you do that. And here, you evaluate the inverse, this inverse here at f of x. F of x is the expression 5x plus 3 over x minus 4. And then when you simplify that, you should arrive at x.